Hi everyone. So today I'm going to talk about Docker networks and how networking happens within Docker containers. So Docker provides us a few different types of network drivers. Some of them are listed here on this page, which are bridge, host, overlay, ipvlan, macvlan, and none. The bridge one is the default network. If you do not specify any network driver explicitly, bridge is the one which is used by default. Let's see what are the default networks which Docker came pre-installed with. So to see that, you can use this command docker network ls. So you will be able to see bridge, host, and none are the three which are by default configured when you install Docker. Let's start a Docker container now without providing any default network to it in the command and see what is the behavior. Docker run -it. I will give it a custom name, container1, and I'll use the Alpine image. So let me try pinging google.com. Yes, I'm able to ping google.com. As you can see, all the packets were received and there was 0% packet loss. Now let's see which of these three networks did this container get connected to. So to check that, we will check these networks one by one. So the command for that is docker network inspect bridge. So bridge is the name of the first network, and we can see the containers running here contain the container one, which is the container which we just started. So it means by default, if you do not provide any network driver, bridge is the one which is going to be assigned by default. Let's now try to run another container of Alpine inside the bridge network itself. So now another container is running inside the bridge container, and this is the IP of container 1. Let's say from container 2, if I want to reach to container 1, is it possible or not? So to check that, inside container 2, I will do ping 172.17.0.2. Yeah, I am able to ping container 1 as well. So to summarize, the bridge network, it is the default network into which your containers will be assigned if you do not provide a network name. And inside the bridge network, your containers can communicate within each other as well as communicate with the internet. Now let's check another type of a bridge network, but this time instead of the default bridge network provided by Docker, we will see the bridge network which is user defined. We can do docker network create and specify the driver, which is bridge in our case, and the name of the network. Let's say my bridge network. So the network has been created. Let me run docker network ls again, and yes, we can see our custom bridge network has been created with the driver as bridge. Now let's start some Docker containers and connect it with our bridge. Docker run, and here we will pass another argument, network my bridge network, and let me rename it to container 3 now. So we are connected. Let me inspect. Yeah. So we can see container 3 is present in my bridge network. Let's try to ping google.com from here. Yeah, we are able to do that. Let's start another Docker container inside the bridge network. And let's call it network 4. And let's try pinging our container 3 from here. Yeah, we are able to do that. So as you saw, I use the name of the container 3, in order to ping. In user defined bridges, you can directly use the container name to ping to that container instead of using the actual IP 172.18.02 in this case, which we could see in the output of docker inspect command. And this feature is not available in the default bridge. So if you ping container 3 inside the default bridge network, it won't work. But inside your custom bridge networks, it will work perfectly. Let's now move on to the host network driver. So I'll quickly start a Docker container in the host network now. Instead of my bridge network, I will provide host here. And instead of container 4, let us use container 5. So the container has started. Similarly, I'll ping google.com and I'm able to do that. Let's inspect our host network. Yeah, container 5 is available, but you can see the IP address section is blank. Why is that? When we specify the network driver to be the host network driver, the Docker's network fuses in a way with your host system's network driver, and the IP of your host computer itself becomes the IP of the container as well. So the host network driver removes all isolations between container networks and the host network, and it almost behaves like the same. Port conflicts can happen a lot in this case. Let's observe one practical difference between the bridge and the host network drivers with an example. So let me start a Docker container in the bridge mode. Docker run -t -it, and I will give it a name, server1, and I will use the nginx image. So nginx has started, and by default we should be able to access it on port 80. But we can't reach it. This is an expected behavior in the bridge mode. Let us terminate this. Let us run another server 2, but this time we will map the port of our computer's 8080 to nginx's port 80, which is its default port. Now if I try to access localhost 8080, I will be able to see the nginx website. Now let's close it again. Let's run another server 3, but this time I will use the network host and will not provide the port mapping. I am able to load the page. So the difference which we observed was, by default, the bridge network doesn't expose its ports to the host computer's network. Hence, even though Nginx was running on port 80, it was not accessible from my computer. To access it, I had to explicitly map the port 8080 of my computer to the port 80 of Nginx container. But when I provided the host network, even without the port mapping, I was able to access the Nginx site. Let's now see the none network driver. Docker run -it name none network container. I will pass the network as none in this and use Alpine. So it has started. If I try to ping google.com now, I won't be able to do it because the none mode disables networking entirely. This provides complete isolation in terms of networks. Let us quickly inspect none as well. Docker network inspect none. So you can see the none network container is available here. Again, it doesn't have any IP addresses assigned to it, just like the host network. But in this case, there is no networking at all. Let's look at overlay network driver. So overlay network driver is used to create a network over multiple Docker hosts. For example, on my local network, let's say I have computer A, B, and C. All of them are independently running Docker and have some containers within them. Using Docker's overlay network, we will be able to create a network between all the containers running over the 3 different computers, and it will appear to the containers as if they are on the same local area network. And the hosts don't even need to be on the same local area network. Let's say me sitting at my home and there is a data center, let's say a cloud machine of DigitalOcean whose IP address I know. If they are able to communicate, we can have a Docker overlay network between those as well. Let's now look at the remaining 2 network drivers, which are ipvlan network driver and macvlan network driver. In the ipvlan network, all the containers within the network share the same MAC address, but they have different IPs. So you can assign static IPs to those containers, or you can let your actual physical router allocate IP addresses via DHCP to them. Similarly, there is another network driver, the macvlan network driver. The major difference between ipvlan and macvlan is, in macvlan, the MAC addresses of each container is different, and it also gets its IP addresses from DHCP or via static allotment. Each driver is specialized. We can choose ipvlan for IP control with some MAC limitations, or we can choose macvlan to simulate actual physical devices on a local area network. And these devices will have a unique MAC identity as well. Let's look at some final commands. For example, let us say I want to get rid of my bridge network now. We can first check, are there any containers running with Docker PS, and then we can try Docker network prune. So this will remove all custom networks that are not used by at least one container. I will say yes, and my bridge network is deleted. So we can check Docker network ls, and that network is now removed. We can also specifically target a network and remove that using Docker network rm command. Uh, in case we want to remove one of these three predefined ones, that is not possible. Let's say I try it with the host one. So I will get an error. Host is a predefined network and cannot be removed. I hope this video helped you clarify some of the Docker networking concepts, and further, you can try to explore the official Docker docs and try the commands on your own setup for true hands-on learning. Thank you.